Welcome back. Today we will be talking about tangent and cotangent functions. So as you can see that domain of the tangent is all real numbers except pi over 2 and plus and pi. On the other hand, for the cotangent, we have all real numbers except n pi. The range for both the functions remains negative infinity to infinity because the graph keeps on going vertically, and because of that there will be no local max or local min. Because the sine function is odd function, the tangent is also odd function and same as the cotangent. So when we are talking about these functions, both the functions, they are discontinuous. The period, if you remember that for the period for the sine and cosine function, it was 2 pi over b. For the tangent and cotangent, it is pi over b. So as I said, there is no local max or local min. The reason is because the function keeps on moving vertically. So there will be an asymptote instead. So when we are talking about the asymptote is typically represented with a dotted line, and it is a line where the function will try to approach but it will never touch. So in the transformation parent function a tangent bx minus c plus d, the bx minus c, that is whatever is with the x, that represent the asymptote. So bx minus c is equal to negative pi over 2 and bx minus c is equal to pi over 2. That will be the asymptote. If you remember from the sine and cosine function, so bx minus c used to represent the phase shift. So the asymptote for the tangent function is pi 2 and plus k pi. So every in addition to every k pi, there will be an asymptote. So as you can see from the graph, we have the asymptote at negative pi 2, and then pi 2 and 3 pi 2 and so on. And it is symmetric to the origin. Right, the same as the cubic function, which is also symmetric to the origin. And now let's talk about the intercepts. So x-intercept is k pi is equal to x, and then y-intercept we have 0, 0. You can see from the graph it intersects at 0, 0. So y-intercept is at 0, 0, and on the x-axis it intersects at pi. We are talking about in the 1 period time in the pi interval, because the period is pi, right? So in 1 period where the intersection is, and there is no amplitude in this graph, the same as for the cotangent function. Instead of amplitude, we talk about the asymptotes. So we don't talk about the phase shift, we talk about the asymptotes. The reason why the amplitude is not there, because there is no vertical stretch or shrink, because the graph keeps on going forever in vertical direction. So as you know, the cotangent function is just the reciprocal of tangent. So the same thing but in a different fashion will be there for cotangent function. But remember, when we are talking about the period will be pi over absolute value of b. We don't take the negative values. So because the reason is that because period is nothing but we are talking about the distance, right? So, and the distance can never be negative. So cotangent is 1 over tangent x. We talked about the domain, range, and the period. Now let's talk about the x-intercept. Now one thing to make sure that the x-intercept of the tangent function will become the asymptotes of the cotangent function, because remember they are reciprocal of each other, right? So what was the x-intercept? X-intercept was k pi, right? So that will become the asymptote. Again, this function is also discontinuous because it keeps on going forever in vertical direction. It is odd function. There are no local max or local min. And then we will write about the asymptotes. Remember what we said, the asymptotes are nothing but the x-intercepts of tangent function. So the x-intercept was k pi, so the asymptote in this case will be k pi. And you can see from the graph, all right, we can see the dotted line at pi. and the period is pi. So at every pi we are looking for asymptote. How to calculate? Algebraically it will be bx minus c is equal to pi, or bx minus c is equal to 0. That will give you the asymptotes. Why pi and 0? Because when we are talking about the cotangent, in cotangent the cos is in the numerator, and when we are talking about the cos, we are talking about the 0 and pi, right, on the x-axis. And the reason why for the asymptote for the tangent we consider negative pi over 2 and pi 2, because those are the sine values, and in tangent the numerator is sine function, right? So the x-intercept is the pi over 2 plus k pi, because the reason is that the cos function is 0 at pi 2 and we don't have y-intercept. So that is a interesting pattern in this case. Now this is how this is the comparison between the two graphs, and you can see the period for tangent is pi and for the cotangent it is pi. When we are talking about the period, we are talking about the one cycle that is being completed. The x-intercept of tangent will become the asymptote of cotangent, and the asymptote of cotangent will become the asymptote of tangent will become the x-intercept of the cotangent. And that is why they look opposite. The graphs look opposite because the function are reciprocal of each other. So as we discussed, the period of this graph is pi over b, and then vertical asymptotes, it happens in the odd multiples, and for the cotangent function it is the multiples of period. The most important thing that will really help you to graph these functions is called the halfway values. So we discussed about the x-intercepts, we discussed about the asymptote, but there will be a value in between the x-intercept and the asymptote. That value is called the half value. So to calculate the half value, we are dividing the whole entire period with 4. So that is the whole purpose for the tangent and for the cotangent. So keeping that thing in mind, let's take one example. And when we will do this example, we will do step by step so that we can cover all the points. The graph is already given, but let's see how we can solve it and match it with the graph. But just by looking at the function, we can understand that there is a vertical stretch by a factor of 2 and a horizontal shrink by a factor of 1/3. So a is 2 and b is 3. Right, and then we can calculate intercept. So the intercept, because it is a tangent function, so the intercept will be at 0, 0, and the period will be pi over absolute value of b. What is b? B is nothing but the coefficient of x. Coefficient of x is 3, so the period is pi thirds. So that is my one cycle. The one cycle is completed in pi thirds. So asymptote for tangent. Remember, in the tangent, sine is in the numerator. So think about the numerator where sine will have the value. It will be at pi 2 and negative pi 2. So bx minus c should be equal to pi 2 and bx minus c should be equal to negative pi 2. There is no c in this case, so we will just substitute bx, which is 3x. So 3x is equal to pi, negative pi over 2, and 3x is equal to pi over 2, which will give you negative pi sixth as one asymptote and positive pi sixth as the another asymptote. And you can match from the graph that on the graph we have negative pi sixth as one asymptote and the another asymptote is pi sixth. Intercepts is at 0, 0. And if you look at the interval is pi thirds. But let's calculate the halfway. So the halfway is nothing but the period divided by 4. So pi over 4b comma a, and negative pi over 4b comma negative a. So we have pi over b as pi thirds times 4, so pi twelfths, and b is 2, so pi twelfths comma 2, and the another value will be negative pi twelfths over negative pi twelfths and negative 2. And you can see from the graph, at pi twelfths the maximum height the graph is reaching is 2, and at negative pi twelfths the dip in the graph is negative 2. So these half values help us to graph the points methodically. So let me label on the graph the halfway points. This is pi twelfths comma 2, and this is negative pi twelfths comma negative 2. This is negative 2. Yeah. Rewrite it again. Right. So let's take another example with the cotangent function, and we will calculate each and everything. But let's label the asymptotes first, which is pi sixth and negative pi sixth. Right. I hope the tangent function was clear. Now look, let's move ahead with the another example. Now we have COT 1/2 x. If I look at the function, I know a is 1 and b is 1/2. So that means we have a vertical stretch, but it is a tangent and cotangent function. So we are not talking about the vertical stretches as such, but just for understanding what we are talking about, a is 1 and there is a horizontal stretch by a factor of 2 because the coefficient of x is 1/2. So just try to relate with the sine and cosine function. So the period, again, it is pi over absolute value of b, which is 2 pi. So one cycle of the cotangent, this cotangent function will be completed in 2 pi. So on the graph, this is the 2 pi interval that will finish the one cycle. Now the asymptote, now understand cotangent. Cot is, we have cos in the numerator, and cos, we talk about the horizontal axis, that means 0 and pi. That is why bx minus c is equal to 0 and bx minus c is equal to pi. That will give you two asymptote, one at x is equal to 0 and the another will be at 2 pi. Now in this case the period is also 2 pi and the asymptote will also happen at 2 pi. When we are talking about the intercepts, intercept will be at pi comma 0. So the intercept at pi comma 0. How? Because pi over 2b comma 0. So pi over 2 comma 1/2 0. It should be divided. I by mistake I wrote times 1/2. It is not times 1/2. This is pi over 2 and the denominator is multiplied with 1/2. So that will be given as pi comma 0. Now to calculate halfway for the cotangent function, we have 4 pi fourth b comma a and 3 pi over 4b comma a, negative a. So if we calculate this, we will get 4 times 1/2 comma 1 and 3 pi over 4 times 1/2 comma negative 1. So this will give you pi 2 comma 1 and 3 pi 2 comma negative 1. And you can see from the graph at pi 2 the maximum height the graph is reaching is 1, and at 3 pi 2 the lowest point on the graph is reaching at 3 pi 2 is 1, negative 1. That is how we can graph the cotangent function and label it properly. Let's practice one more, and this time we will match the answers with the table as well. So if you look at the graph, you know A is equal to 2 and B will be 1/3. The graph is already given, but we will calculate each and everything and we will match with the table. So A is 2, B is 1/3. So the period will be pi over B, and B is nothing but 1/3. So the period will be 3 pi. So one cycle will be completed in 3 pi. Right. Now let's talk about, remember it is a COT. So the intercept will be at pi over 2b comma 0, which will be at 3 pi over 2 comma 0. Now the asymptote, for asymptote we are talking about the cos. That means 0 and pi. So bx minus c is equal to 0 and bx minus c is equal to pi. If you compute this, you will get the asymptote at x is equal to 0 and at x is equal to 3 pi. The asymptote implies that it is undefined. You can see on the graph the x-axis, the x and y axis. So we are getting at x is equal to 0, one asymptote, and at 3 pi another asymptote. Halfway will be pi over negative 4b comma a, and 3 pi over 4b comma negative a. So that will be 3 pi fourths comma 2 and 9 pi fourths comma negative 2. So on the graph you cannot see properly negative 9 pi fourth comma negative 2 because it is not labeled properly, but you can see between pi and 3 pi there is a point, and that is giving the value as negative 2, and this is how the table will look like. And this table matches with all the calculations we have made. See, 3 pi over 4 and 9 pi over 4, those are the halfways. So between 0 and pi, we have a halfway, and between pi and 3 pi, we have another halfway. And then the intercept is also listed in the table, and the same as the asymptotes. Asymptotes, it's where it says it is undefined, those are nothing but the asymptotes. So if you keep these things in mind, calculating each and everything properly, then it will match. Now let's talk about the cosecant and secant function. Now remember, cosecant is the reciprocal of sine function, and it is also discontinuous. The domain, range, and period, they are listed on your screen. The secant is the reciprocal of cos function, and you can see from the graph they bounces on the sine function or the cos function. So cosecant function will bounce on the sine function and the secant function will bounce on cos function. These sine is odd, that is why cosecant is odd. The maximum for cosecant will happen at 3 pi over 2 plus 2k pi, and the minimum will happen at x is equal to pi over 2 plus 2k pi. So basically the maximum of cosecant is nothing but the minimum of the sine function, and the minimum of cosecant is the maximum of the sine function. So basically when we have to graph the cosecant function, we will first sketch the sine function and then we will match with the cosecant function. Now when we talk about the asymptote for the cosecant function, so the asymptote, remember it is a reciprocal of the sine function, right? So the asymptote will happen at k pi. So this is same as x-intercept of sine function, because sine and cosecant, they are reciprocal. And the intercept will be none for the cosecant function, because cosecant function, it bounces up on the max and mins of the sine function. Yes, so if you can see on the graph, the U shape, it is a bounce on the max. Downward facing U is the bounce on the min of sine. So the same thing with the secant function, max is 2k pi and min is pi plus 2k pi. And the max is nothing but the minimum of cos function, and the minimum of secant function is nothing but maximum of cos function. And when we talk about the asymptotes are nothing but the x-intercept of cos function. And because cos function is even, secant function is also even function. In this case, when we are talking about the intercept, there will be an intercept at x-intercept will be none, but the y-intercept will happen at 0, 1. Because in the cos function, we have a max at 0, 1, right? So this is how the graph will look like. So the first function is for the cos, and you can see cos has the maximum or the hill at 0, 1. That is why secant has the intercept there. Even though the sine function has the intercepts, but not on the max and min. So the intercept for the secant function is at the max of the cos function. Let's take one example. And as I so earlier, to graph the cosecant or secant function, we need to first graph their reciprocal, because we know how to graph the sine and cos function. So the first thing is, first graph the sine function. So we will change this function into a sine function. So let's say y is equal to 2 sine of x plus pi fourths. So in the sine function, we are talking about the amplitude. So amplitude is equal to 2 and the absolute value of b is 1. So the phase shift, that means bx minus c is equal to 0 and bx minus c is equal to 2 pi. So the phase shift will happen at x is equal to negative pi fourths and x is equal to 7 pi fourths. This is how the phase shift will work. Now on the right hand side you can see the graph, but I will show you the graph of the sine function to make it more clear. Now when we are talking about the x-intercept, so the x-intercept will happen at negative pi fourths. So when we are talking about the x-intercept, we are talking about the x-intercept of sine function. And the x-intercept of the sine function will work as the asymptote of the cosecant function. Right? So the x-intercept will happen at negative pi fourths, 3 pi fourths and 7 pi fourths. Period is 2 pi. So let me write all the x-intercept before I forget. Negative pi fourths, 3 pi fourths, and 7 pi fourths. And these x-intercepts, they are nothing but the asymptotes. So this is how the sine function will look like. I graphed it on the Desmos, and just you can see the points, all the points, the x-intercepts between the interval we are talking about. So negative pi fourths, we have 3 pi fourths there, and then 7 pi fourths. So these intercepts will work as the asymptote of the cosecant function, and the cosecant function will bounce up or down on the max and min of the graph, of the sine graph. Right? So this is the period that we are looking for, the whole entire thing. And then if we go back up, so the period is when one max and one min will happen, right? So between negative pi fourths to 2 pi, where those two asymptotes are there. And you can see the cosecant function bounces up on the max and bounces down on the min functions. So as a rule of thumb, if you have to graph the cosecant function or secant function, always graph their reciprocals, because graphing the sine function and the cos function, they are easy, and wherever there is a max or min, at those points the cosecant or secant function will bounce up, and the intercepts of the sine and cos function will work as the asymptote. So this is the whole entire gist of graphing tangent, cotangent, secant, and cosecant function. Just practice, and I hope it will make more sense, and I will see you in the next video. Bye bye.